Okay, thank you. So I'm speaking here from sort of three different perspectives. One is, as well, they're very similar perspectives. Until recently, I was director of the ICIS neutron and muon source in the UK, so I have direct experience there with all the user access and things. I'm currently chair of the League of European Advanced Neutron Sources, LENS, so that's a broader consortium, and I'm also representing Analytical Research Infrastructures in Europe, which is an even broader consortium. Okay, so to let you know what ARIE is, it's a consortium of consortia. So it covers 7 different types of research infrastructures, from, it said, neutron sources, photon sources, LEAPs has already been mentioned, lasers, and so on. So there's a very wide variety of types of research infrastructures, but typically linked by the fact that we are analytical research infrastructures, mainly, but not totally working in the physical sciences. But to give the scale, our consortia encompass, depending on how you count them, about 100 different European research infrastructures, and we support something like 40,000 researchers from academia and industry. So it's a very large user access issue, and obviously these issues of remote access are therefore quite important and diverse. But first of all, I'll just distinguish various types of remote, because remote doesn't just cover a single thing. What I will call mail-in sometimes goes by different names. That's essentially where a user sends a sample, the facility does the experiment, the user gets the data later, and that's just been mentioned, for example, as a mode in Instruct-ARIE. In remote access, the user might send the sample, the facility still performs, that is, it controls the experiment, but the user is present and participating remotely and taking part that way. And then again, the user receives the data. Remote control is a step further, where the user is now able to control part of the experiment remotely, or indeed all the experiment remotely. And then I'll add what I call remote collaboration. That's all the activities not involving an experiment. I mean, so data analysis is one example, but there's lots of other examples there. And I'd note that, I mean, a lot of this comes from experience during the pandemic, where we, of course, increased remote access a great deal. That experience did depend on local and national restrictions, which were different. There were different working from home directives, there were different social distancing, etc., in different countries. So that experience was different. But to some extent, I'm trying to extrapolate that to what might be possible without such restrictions. And I'll sort of very rapidly give the summary and then the conclusions, but then I'll go into more detail. It's very important to understand, even within these research infrastructures, they are different. Even the instruments, the scientific instruments of the different research infrastructures themselves may be different in terms of what's possible with remote access. Experiments are different, and indeed users are different. So there is no single solution to this whole issue. And I'm just showing here 2 examples. So on the left, you have these are mounting pucks where you mount protein crystals, which are sent to synchrotrons for protein crystallography measurements. This is nowadays highly automated. So the users mount them, they send them off, they get the data back, and they can send hundreds and hundreds of samples at a time. On the right is a tweet that turned up a couple of days ago, coincidentally, another experiment at a synchrotron, with somebody pointing out they're shipping 1,000 kilograms of equipment for a single experiment to do an in situ experiment. It's fairly obvious that the one on the right does involve a lot of user participation, and it is unlikely to be feasible remotely. It might be, but it's unlikely to be feasible. The one on the left is essentially very adapted to be remote experimentation. And of course, the conclusion will be that, of course, some remote working is perfectly feasible and highly effective and is already happening. And some remote working that people might like to do is actually impossible. But generally, of course, most of the tools and protocols and systems you develop for remote working are actually very helpful, even when you don't have remote working. So to give my specific experience over the last couple of years from the ICIS neutron and muon source, so just to, I mean, again, a relatively important thing to point out, that some research infrastructures, when they're operating, operate 24 hours a day. 7 days a week. That's not true of all research infrastructures and all types of things. And so that's quite an important difference in understanding what is possible remotely. And certainly for neutron sources, many or indeed most experiments involve complex sample environment, or they involve sample synthesis during the experiment. There's relatively few routine measurements as repeatable measurements like, say, protein crystallography. For those, we've had mail-in available for some years, but that's a relatively small proportion of what can be done. So during the pandemic, we actually managed to use about 75% of the available beam time. The picture at the bottom is just a sort of booking over days of all the various instruments that are available. And that's comparable to about 90% in normal circumstances. In normal circumstances, you still don't run absolutely everything all the time. But that was done with about 5% of the normal number of user visits. Typically, ISIS will have something like 4,000 user visits in a year. So that was a very small number of user visits, which were the bits that were absolutely necessary to carry out those experiments. So generally, that was extremely successful application of remote working. Mainly, it was remote access. There is very little remote operation of instruments because of safety constraints, particularly moving machinery is difficult in remote things, but there's all sorts of other constraints that you. This is not to say that remote operation is not possible, because in fact, a facility like ISIS will have its instrument scientists, its technical support, etc., will actually be able to do things remotely, because again, you're offering 24/7 support, and all these people are not on site all the time. But that's a very limited number of people who are expert in the systems who are allowed to operate things remotely. For general user access, that would not be possible for safety reasons. The data analysis access worked extremely well for us. That was actually because in the previous years, we've been developing a data analysis as a service system, which had been rolled out onto a number of instruments before the pandemic. And we were able to then put a lot of effort into rolling that out across all instruments. So the data analysis, and that's something which now will benefit in everything in the future. So that's really well developed. And there are other facilities have similar systems. But the remote access was a case of no choice during the pandemic. The overwhelming view is that level of remote access is not sustainable in the long term. As a 24-hour-a-day operation, staff overload can be a serious problem. And if you were going to have a higher proportion of remote access, generally, you would need a larger number of staff to be able to cover that. As personal contact decreases, the collaboration dynamics do change. And the collaboration is for many facilities, a key part of their success. There's a big difference between simply being a service provider and a collaborator. And I think we need to understand that difference. It's very important that people talk to people for a lot of experiments to be successful. Remote access also loses most of the training aspects. So it's actually users coming to do experiments is where they get trained. It's a very large part of the training of students and postdocs and so on. And if users become less experienced, then of course the burden on staff goes up because they have to do more, training. And actually, users lose that large facility experience. Actually, some people find doing the experiments exciting. It's really quite a big deal for them. And I think I'd also point out that ownership, what I'll call ownership of experiments, it doesn't mean that the data don't actually belong to the people who did it. But if you spent 4 or 5 days working 24 hours a day to collect a certain set of data, you really feel you own that data and you want to make the most of it and publish it, etc. And there's a feeling that that level of ownership can decrease. People think it's slightly less important because they didn't have to put the effort into it. Extrapolate, so across most of the neutron sources, that was a very similar experience because we do very similar experiments. For the synchrotrons, it's a bit different because a lot of the beam time, as I said earlier, was already automated mail-in, essentially, so protein crystallography. So that simply through the pandemic continued very effectively. And of course, that was very important because of the results related to COVID and so on. So that aspect of synchrotrons continue very effectively, but many of the other experiments, like illustrated in situ experiments, the experience is very similar to LENS, because again, it's very similar to the neutron facilities. In the case of the high magnetic field laboratories, this is fairly obvious in those cases that safety constraints on high magnetic fields are quite extreme, and therefore remote access and control is really a lot more difficult. People really need to come and do their particular experiment. So actually a lot of experiments were cancelled. Mail-in experiments were performed, though they're possible in some other areas, and that was feasible because the number was reduced. But there's no way really that for high magnetic field laboratories you can carry out the same level of program with a very high proportion of remote access, unless you had an enormous number of staff to do that. In the case of lasers, then quite a lot, laser experiments fall into some different categories. Some of them actually involve the laser setup itself and working with the lasers itself. And so strong user participation is essentially, is absolutely necessary for those experiments to take place. It's not just about shining a laser on a sample. For those things that were possible, it was mainly remote access. Remote control was limited, again, for the safety reasons. So that meant for laser facilities, there were typically a reduced number of experiments. For the laser lab itself, we've got the very precise number of 61% carried out remotely, or hybrid. That means with user participation remotely. But again, they very much made the point that hands-on training was lost. Going to other aspects of remote access. So as I already mentioned data. So there were many tools for remote access to data analysis, but they've certainly been improved, extended, and that's really, really good. Some training can be virtual. You can do some aspects of it. And that was also developed during the pandemic, but hands-on is important for many experiments. And indeed, hands-on training courses tend to be very heavily oversubscribed exactly for that reason. We, of course, found that meetings and conferences, there was a lot of development in tools and techniques, and that improved a lot. Entirely remote tended to be quite successful. Hybrid meetings with meetings and conferences, very mixed experience. All of that's improving. One thing we certainly found was that seminars, everybody coming in remotely enabled a much higher and broader audience than people having to come in person. But of course, then you got potential overload because you had too many options of seminars you could go to. But that was certainly a success. Things like experiment selection panels, as that selection has been mentioned previously for Instruct ARIE, for example. Our experience was that these are possible, but the amount of discussion was much reduced, and therefore there are some disadvantages to doing that if you wanted to do that. Where you have selection panels which are discussing hundreds of experiments over a couple of days, really difficult to do that remotely. So this is the SWOT analysis, strength, weaknesses, opportunities, threats analysis we did for ISIS. So the top left, we had the strength, which is, of course, with remote access, we can continue operations in a pandemic. We delivered a large fraction of the user program. The staff responded very positively and actually enabled that. So in the future, you think you'll still be able to do that again if you needed to do. And the user community were highly appreciative of what we did. The environment was safe. That was because there was limited remote access, and of course, COVID relevant research was done. The weaknesses is that the efficiency went down. We didn't do as much as we could do. Fewer users on site, less collaboration. There were no visits. By visits here, I mean non-experimental visits. So schools, etc. Again, a very large important thing that many facilities do, which does require people to come to the facility. Project delivery, so that was more difficult. And I mentioned the question about experiment ownership and staffing model. The opportunity is hybrid experiments. That is where we have partial remote access, partial people coming on site. We think that will become a lot more common, and that enables you to have a wider inclusion, and we're discussing that this afternoon. Automation software has developed much more quickly. That enables some things to be more efficient, and people have developed new skills, better communication technology, and different ways of communicating with the community. But the things we really worry about are training, that being much more limited, no hands-on training, weakened collaborations, I mentioned already staff overload and how that affects future working patterns. So looking to the future, my conclusions would be that increased remote working will require either both increased and different facility staff. And there is a cost. The cost to the facility does increase. Does not come for free just because it's remote. Some measurements can be highly automated and are very suitable for remote access. So talking to some synchrotrons is a very rough figure, but maybe 50% of some synchrotron experiments can actually be done very effectively remotely. But for example, for the magnetic field, it's a very low percent that could be done. Some experiments will always require users on site. But as said, capabilities developed for remote experiments can also be very useful for non-remote experiments. There's a likely increase in hybrid experiments. I do worry a little bit about the problem then of the supervisor sends the students do the experiment and doesn't come themselves, and therefore again that puts more load on the instrument scientists locally. So hybrid can be good, but it can also be bad. But the final point I want to make is that people are talking about we need to reduce travel to reduce the carbon footprint. You should not assume that the net carbon footprint is reduced by reducing travel. If a higher proportion of remote working leads to decreased efficiency, then the carbon cost of operating a lot of these facilities is very high. And if you decrease that efficiency by 10%, that probably wipes out any gains you made in carbon footprint by people not traveling. So it's a more, I think that's a simplistic way to view the reason we need to do remote experiments is it simply decreases travel and saves on carbon. It's a lot more complicated than that. Thank you.